Our first lesson in this new unit on bonding is going to be about ionic bonds. So the name is bond, ionic bond. So let's review a little bit of our periodic table. So the periodic table is periodic because it contains certain trends that we've noticed in elements. So some of the trends we haven't talked about yet, but size, ionization energy, electronegativity, metallic, non-metals, metalloids. So we can use our periodic table to predict some properties of our elements. So our periodic table, remember, is divided into three main classifications. So we have our metals in blue, we have our metalloids shown in pink, and we have our nonmetals in yellow. So when we talk about ionic bonds, it's going to be important to know the difference between a metal and a nonmetal. So you have this kind of stair step drawn on your periodic table. The rule of thumb is anything to the left of that stair step, so over in this direction, is really a metal, considered a metal. Anything above that stair step is usually a nonmetal. So as we move from right to left across the periodic table, we become more metallic. So our nonmetals are over here, less metallic, more metallic as we move this way. Also, as we go down the periodic table, we also become more metallic, so more metal-like characteristics. So let's use that periodic table to answer a couple questions. So in the periodic table, the elements are arranged by what? So think back to when we talked about the periodic table. Is it A, alphabetical order, B, order of increasing atomic number, C, order of increasing metallic properties, D, order of increasing neutron content, E, reverse alphabetical order, or F, I don't know the answer to this. So the answer should be B, by atomic number. So hydrogen is 1, helium is 2, lithium is 3, and so on. So we arrange them by their atomic numbers. Next question. Elements blank exhibit similar physical and chemical properties. Is it A, elements with similar chemical symbols, B, elements with similar atomic masses, C, elements in the same period of the periodic table, D, elements on the opposite sides of the periodic table, or is it E, elements in the same group on the periodic table? So answer should be E. Elements in the same group, remember groups are your columns, are going to have similar physical and chemical properties. Next question. Which pair of elements would you expect to exhibit the greatest similarity in their physical and chemical properties? So remember what we just learned. So things in the same group, remember group or columns, are going to have similar properties. So we want to find a pair that is in the same column on the periodic table. So take a minute to look up your elements and figure out which one is the correct answer. So answer should be A, lithium and sodium are both in the first column. So which of the following is a nonmetal? So let's use our periodic table and figure out which one of these is a nonmetal. So remember, nonmetals are generally to the right of that stair step. So answer should be E, sulfur. Sulfur is a nonmetal. Next question. Potassium is a blank and chlorine is a blank. So take a minute, see if you can figure out what the answer should be. So answer should be A. Potassium is a metal and chlorine is a nonmetal. So now we've kind of reviewed our periodic table. Let's talk about ionic bonds. So one rule that forms ionic bonds is called the octet rule. So it says that atoms tend to want to have a completely filled outer shell. So if we were to draw in our electrons and their energy levels, we want this outer ring to have a full octet. So that means a full number of 8 electrons. So magnesium, if we were to draw it, has 2 in its outer energy level. So it doesn't have a full octet. So what happens with magnesium when it forms an ionic bond is that these 2 electrons leave. And so now its ring would have on the outside 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons in the outermost energy level. So we call those valence electrons, the ring and electrons in the outermost ring. And so when an ionic bond forms, it's because of this need to have 8 electrons in the outermost ring. So how do we know how many valence electrons something is going to have without having to draw those pictures? So valence electrons, again, are the electrons in the highest energy level. So here's a picture. This atom would have 1 valence electron out there. So valence electrons are going to determine the chemical properties of your elements. So how do we know without having to draw these complicated pictures? So atoms in group 3 are going to have 3 valence electrons. So column 3, 3 valence electrons. Atoms in group 17 are going to have 7 valence electrons. So here's a picture that kind of shows you the number of valence electrons in these atoms. So the first column, and if you want, you can write these right on your periodic table. First column is 1, second column is 2. Our transition metals are picky, so they can be 1 to 4. Third column is 3, fourth column is 4, so on and so forth. So all the way up to our noble gases being 8. So if you want, write these right on the top of your periodic table. So let's practice using that. So potassium has how many valence electrons? So first we want to figure out what column is potassium in. And so potassium is K, located in the first column. So first column means it would have B, 1 valence electron. See if you can figure out this one. How many valence electrons does aluminum have? And the answer should be C, 3. It's in the third-ish column. Skip over the transition metals. How many valence electrons does barium have? So answer is 2. Barium is in the second column, has 2 valence electrons. So true or false? Arsenic has 6 valence electrons. It should be false. Arsenic only has 5 valence electrons. Okay, let's move in then to talking about ions. So ions are atoms or groups of atoms that have a charge associated with them. So they've either gained electrons and are now negative, or they have lost electrons and are now become positive. So a group of atoms with a charge. So cations are going to be positive ions. So things that have lost electrons. So if you've lost negative charges, you become positive. So the way I remember it is cats have pos, so they're positive. So cations are positive. And they're usually found on the left side of our periodic table. So our metals tend to be cations. So here you can see an example. So everything in the first column, if you notice, all has a +1 charge. Everything in the second column is a +2. Aluminum over here is a +3. Anions then are the opposite. So they're negative ions, and they have formed because our atom has gained extra negative charges. They've gained negative things. And these tend to be our nonmetals. So here you can see sometimes hydrogen is a -1. But for the most part, usually it's going to be positive. But fluorine, chlorine, bromine, you can see they're all -1s. Oxygen, sulfur, selenium, tellurium are -2s. Nitrogen's -3. So how do cations form? So metals are going to usually give up or lose those valence electrons. So those electrons in the outermost energy level to become stable. So sodium is in the first column, so it's usually going to give up 1 electron, and it becomes positive. So 11 protons still sodium, except now it's lost an electron, it has become positive. So it has 10 electrons instead of 11. So here's kind of what it would look like. So magnesium has those 2 valence electrons. It's going to give those 2 up, become a positive 2, and those 2 electrons are going to go other places. So you can see the first column always are +1s, second columns are always +2s. Anions are going to form by gaining extra electrons. So example is chlorine here. 70 protons, 17 electrons. So chlorine is going to gain 1 more electron and become 18 for its total, and it will become a -1 ion. So usually group 15 are always going to have a charge of -3. So anything above the stair step, though. Group 16, oxygen's column, again above that stair step, they're going to be -2s. And group 17 are usually going to be -1s. So let's answer some questions. So metals tend to blank electrons and nonmetals tend to blank electrons. So metals tend to lose electrons and they're going to become positive, and nonmetals tend to gain electrons and they're going to become negative. So our answer should be D, metals lose, nonmetals gain. So anions tend to be blank and cations tend to be blank. So anions tend to be nonmetals and cations tend to be metals. So true or false, metals lose electrons to form cations. Answer should be true. Metals are going to lose electrons, become positive. So calcium forms what ion? So first we want to figure out what column is calcium in. Calcium is in the second column. So anything in the second column is usually always going to be a positive because it's a metal. And because it's the second column, it's going to be a +2. So our answer should be B. Phosphorus forms an ion of what charge? So let's find phosphorus. Phosphorus is in nitrogen's column. So nitrogen is column 15, and those are going to become a -3. So our answer would be D, phosphorus is going to form a -3 charge. If you want, you can also write over the column numbers what charge they would normally form. So let's try another one. Aluminum forms an ion of what charge? So here we kind of think of this as 1, 2, 3. So it's going to be a metal. So we know it's positive, and it's going to be in the third-ish column. So we would say +3. So C. So last one. Of the following, what contains the greatest number of electrons? So phosphorus, normally by itself, if you look, will have the same number of protons as electrons. So phosphorus is number 15. So when it's neutral, has 15 electrons. If it's a +3, that means it's lost 3 electrons. So we will be down to 12 electrons for a +3. Let's do the other positive. So for a +2, we've lost 2 electrons, we would have 13. Now if we are negative, that means we've gained electrons. So phosphorus -2 has gained 2, so it would be 17 electrons. Phosphorus -3 would be 3 extra, so it would be 18 electrons. So our answer should be D on that one. Okay, last thing, let's talk about the different types of bonds. So ionic bonds form from our 2 ions, our cation and our anion. And they form because the positive and negative atoms are attracted to one another. So we call that an electrostatic attraction. So our positive and negatives attract. 2 other types of bonds that we'll talk about in later units are covalent, which form by sharing electrons. Remember, ionic is the transfer of electrons. So one becomes positive, one becomes negative. Covalents form from sharing electrons. And the metallics form by a bunch of electrons being shared together. We're going to focus on in this unit just the ionic bond. So ionic bond occurs when a positive and a negative ion come together and are formed. So we get that attraction, and we call that an electrostatic force. So ionic bonding forms ionic compounds. We're going to talk a little bit in a different part of this unit on how we name and write those formulas. But again, they're composed of ions, but the overall compound is neutral. So even though if we look at the parts, we have a positive part and then we have a negative part, together they cancel one another out and create a neutral compound. So of the following, which can form an ionic bond? So when we're asked this question, we want to find a metal and a nonmetal, a positive thing and a negative thing that would come together. So if we look at A, lithium becomes positive 1, but neon does not, it stays 0, so can't be A. B, we look at potassium. Potassium is a metal, it's in the first column, so it's positive. Bromine is a nonmetal on the far right, would become negative. So that could be our answer, potassium and bromine. C, potassium, again, we know is metal. Cesium, though, is also a metal. So two metals can't form an ionic bond. We have to have a metal and a nonmetal, a positive and a negative. D, sulfur is a nonmetal and chlorine is a nonmetal. So again, it won't work. We need a metal and a nonmetal, a positive cation and negative anion. So our answer was B on this one. So see if you can figure this one out. Which of the following will form an ionic bond? And our answer should be D. Sodium is our metal, chlorine is our nonmetal, forms an ionic bond. Positive, negative, metal, nonmetal. Okay, let's try another one. Which of these would be an ionic bond or ionic compound? Answer should be C, strontium and chlorine, metal, nonmetal. Hydrogen is tricky. Usually hydrogen does not act as a metal. So our answer should be C on that one. So what are some properties of things that are ionic compounds, have ionic bonds in? So ionic bond is the strongest of those three bonds. Very strong. That positive, negative electrostatic force is very strong. So they form crystalline solids. So they have these unique arrangement of crystals at room temperature. So most of them are solids. There's only one exception to that. Most are going to have really high melting points. So in order to melt them, we have to break some really strong forces. They're also going to be good conductors of heat and electricity. And they dissolve really well in water. So we're going to do a lab later on where we test some of these properties.